Hi, this is Christina Plochet, and this is my final presentation for CIT 260, Object-Oriented Programming. Let's get started by talking about static and non-static variables. A static variable is one that's associated with a class, not objects of that class. When a class member is declared static, it can be accessed without creating any objects of its class. Non-static variables are also known as instance variables and are used by objects to store their states. Variables, which are defined without the static keyword and are outside any method declaration, are object-specific. They are called that because their values are instance-specific and are not shared among instances. When you need to define a class member that will be used independently of an object in a class, you should use a static variable. Let's look at this in the code for the control layer in our game. The control layer is full of static class variables. A non-static class member must be accessed through an object of its class, but with a static member you can create it to be used by itself by preceding the declaration with the keyword static, as you can see in the code examples here. These are essentially global variables. When an object is declared, no copy of a static variable is made. Instead, all instances of the class share the same static variable. You can declare both methods and variables to be static. In the code examples for both the game control and the crop control classes, you can see that both variables and methods using the static method. And you can see that here, these are variables, and then here is a static method. Same thing in crop control. These are variables, here's a static method, here's another static method. An interesting note is that the most common example of a static member is main, and this is declared as static because it must be called by the JVM when your program begins. Another example of a static method is the square root method, which is a static method within Java's standard math class. Now let's move on to how to use a static class. To use a static member, you need only specify the name of its class followed by the dot operator. No object needs to be created. We can see how this is done in the code for this crop view class. Calcland cost is used as a variable for the price, and we can see that this was created as a static variable in the crop control class over here. Now let's look at the code in the model layer. You can see from the crop data class in the model layer that it uses non-static classes or instance variables. These variables are not preceded by the keyword static. They are associated with objects. You can see that these objects like year, population, acres owned, people fed, etc. here, and these are used throughout the game. Now let's look at arrays and enums. Array list, and enums. When to use them. So when to use arrays. Arrays are fixed length lists that may contain either primitive values like byte, short, int, long, float, double, boolean, or char, or they are objects created from classes. All of the elements in the array must be of the same data type. Use an array when the length of the list is fixed and all the data are of the same type, and you may want to dynamically change some of the items in the list. The map class is a good example of this. It creates an array for the location objects, as you can see here. The array is a fixed length, and the row and column are of the same data type, in this case, integers. When to use array list. Java ships with a class called an array list. This class allows you to create variable length lists of objects. You can dynamically add and remove objects from the list. The objects may be of different data types. Primitive values cannot be put directly into an array list. They must be converted into an object before being placed in the list. In the game control class, we can see the use of the array list. We needed to use the array list here because the number of items changes and because the object uses different data types, char and int, or character and integer. We had a little fun in our game by using coconut cream pie as one of our provisions, and of course this number is going to change throughout the game. You may start out with 200 pieces of coconut cream pie, but you certainly won't end up with that many because of course everybody wants some pie. So you need to use an array list so that this can be updated. All right, when to use an enum. You use enums when the list length is fixed. The list items are constant, and the list items are also of the same data type. An example of enum in our code is from the team member class in the model layer. This is the method called in the list view to list the game authors. The game authors are a fixed length list that doesn't change, and they are all of the same data type. And you can see that here. We're all character data, text data, our names and our titles. The example here is in the list provisions view. Let's talk about this and let's look at some examples of the for statement to loop through the list so that each item and its amount could be printed to the console for use in the game. In my code example, the first statement, system out println, list of provisions in the storehouse, prints out the title of the list. We only need that to print once, so the for statement is placed underneath that. The initialization step is executed first and only once. This step allows you to declare and initialize any loop control variables, and this step ends with a semicolon. In my code, this is the int I equals 0 statement. Next, the Boolean expression is evaluated. If it is true, the body of the loop is executed. If it is false, the body of the loop will not be executed, and control jumps to the next statement past the for loop. In my code, this is the I less than the provisions dot size, which means to continue looping through these statements as long as I is less than the length of the provisions list. Lastly, after the body of the for loop gets executed, the control jumps back up to the update statement. This statement allows you to update any loop control variables. This statement can be left blank with a semicolon in the end, but in my code we use the I++ to increment the I variable and continue the loop. The Boolean expression is now evaluated again. If it's true, the loop executes and the process repeats. Body of the loop, update the step, then the Boolean expression. After the Boolean expression is false, the for loop terminates. So in this case, you can see that these lines keep getting printed for as long as the length of the list is less than the length of the list. So all the provisions get outputted, and this indicates the index number. So this looks for that index number, prints that line, goes back, looks for it again, prints the next index number of the array, and prints it again until it's done. All right, throw and catch errors. If no method is used to throw and catch errors, the program may just abort. This frustrates end users when the program terminates suddenly, so you should always use catch and handle all runtime errors in your program. Let's take a look at what this looks like in the code. The method at the top of the calling hierarchy is responsible for catching and handling the error. It must watch for the specific type exception object being thrown and then take appropriate steps to handle the error in a graceful way. Typically, this involves printing a meaningful message to the console and redirecting control of the program so that the program can gracefully recover from the error. The method at the bottom of the calling hierarchy that detects a runtime error is responsible for creating a new Java exception object instance and throwing or propagating the exception object up the calling hierarchy to the method that is responsible for handling the error. The exception object, that's a mouthful, the exception object represents the error that occurred and may contain a specific error message. In our case, this says there was an error saving the provision list to the file. That way you know the error is coming from the provision list. And we do this by surrounding the code to be watched with a try catch statement. The try block contains the code being executed and watched. In our example, this is the code designed to print the provisions list. We have one catch clause in our code. Each catch clause defines a specific type of runtime exception to watch for in the execution of the code in the try block. Each catch clause starts with the catch keyword, followed by a definition of the variable within parentheses. The data of the type of variable must be one of the runtime exception error classes that come shipped with Java, or a custom exception class created uniquely for your program. In our example, we use exception. The variable inside the parentheses, in our example, the letter E, contains a reference to the exception object thrown and is propagated up the calling hierarchy when a runtime error occurs. The data type of this variable must match the type of runtime error that you are watching for in the try block. Usually the view layer is responsible for catching and handling most all runtime errors, and our game is no exception. It's also in the view layer. All right, char stream, byte stream. A stream is a sequence of data. An input stream reads data from the source. An output stream writes data to a destination. Character streams are in human readable format. Byte streams process data byte by byte, which is 8 bits. For example, file input stream is used to read from source, and file output stream is used to write to a destination. Just a note, names of character streams typically end with reader or writer, and names of byte streams typically end with input stream or output stream. The same methods that you use to write to the console can also be used to write to a disk file. Just a nice little note. Character streams are defined by using 2 class hierarchies, topped by these 2 abstract classes, reader and writer, which we kind of mentioned. Readers used for input, writers used for output, and concrete classes derived from the reader and writer operate on Unicode character streams. So let's talk about when to use a character stream over a byte stream. And when you want to do this is when you want to create a text file. In Java, characters are stored using Unicode conventions. Character streams like this is useful when you want to process text files. They can be processed character by character, and a character size is typically 16 bits. Now, the other question is, why do you want to use a character stream over a byte stream? Character streams are designed for handling the input and output of characters. They use Unicode and therefore can be internationalized, meaning they can be written in different languages. Also, in some cases, character streams are more efficient than byte streams. Use it also if you need the file to be readable by humans. In our code, we can see that this stream ends with the word writer, so that we know this is a character stream. All right, let's look at the byte stream. When to use the byte stream over the character stream. Byte-oriented reads byte by byte, and it's suitable for processing raw data like binary files. In our code here, we can see that the byte streams end with the input or output stream. In this case, it's an output stream. At the lowest level, all input and output streams are still byte-oriented. The character-based streams simply provide a convenient and efficient methods for handling characters. Now, I know this isn't part of the assignment, but I learned this semester and just wanted to share about the buffered stream. When working with input and output streams, we often need to use buffered streams. A buffer holds data. A buffered stream holds data that is being input and then outputs it much like a splash bucket holds water. Of course, you have more control over when the bucket deposits its load, but you get the idea. This visual really helped me to understand the concept, so I hope you like it too. All right, character data to a file. Let's look at how to write the character data to an external file. From the list view, my print provisions list code from my individual assignment uses a character stream to output the data to the file. You can tell this because it's using the word writer. Here you go, right here, which indicates the character stream. Now, I'm just going to talk for a second here. Something I noticed about the code is that the methods to save the game and retrieve a saved game use the byte input and output streams. And I searched the code for character input and output streams, and it shows that only the list view outputs data to character streams. So like the list of provisions, the list of animals, and such. This data is saved as a character stream, but in the end, the entire game is saved and retrieved from a byte stream. So I also wanted to talk about the byte stream for a second. In the game control, in our save game method, we use a byte stream, as you can see here, to write the data to an external file, which is created with the save path variable. The user has to enter the exact file path on their computer in order to save the file to the correct location. This can be saved as either a TXT or DAT file. We did it both ways in our team, and they both worked. And then you have the getSavedGame method calls the file path that the user enters, and the game can resume playing. So let's see how this is done by looking at our game. All right, you can see that we've started the game. So we're going to start a new game, and we're going to type in my first name, which is Christina. And now we're going to play. I will just forewarn you that I'm usually not good at playing games, but here we go. So why don't we try just printing a list, and let's list our provisions because we want to see that. Oh, well, actually I don't want to save the provisions. I want to list the provisions. So now I'm going to return to the game menu and we're going to list the provisions. Let's try that again. So there we go. We've got our sugar, salted pork, beef jerky, and coconut cream pie. All right. All right, so that was fun. Now let's get back to playing the game. How about we manage our crops? Actually, that's our game menu. So we can, there we go. Land is selling for 25 bushels per acre. How many acres of land do we want to buy? How about we want to buy 3? Let's see what happens here. Now we have 1,003 acres of land. How many do we want to sell? Let's say 50. It takes 20 bushels of wheat to feed each person. We have a bunch of bushels in store. How many bushels of wheat do you want to give to the people? How about we give 1,500? We can plant 2 acres. How many acres of land do you want to plant? 500? All right. We want to pay 10% in tithes and offerings. And, oh, I had 25 people starve. Oh dear, new people, current population. I didn't do very well, did I? Let's keep playing. And we're just going to start a new game. We're just going to do a little bit here. And we are going to, let's just return to the main menu. And let's save the game and see what happens, see how we do that. There we go. So we're going to save the game. And now we're going to go look and see if it's saved in my downloads. And there it is. It's saved. So now let's try to play a saved game. And there we go. And we got the saved game. So that's it. We had a great time this semester. Thanks for watching my presentation, and I hope you have a wonderful break.